Hello friends, in this video we are solving examples from miscellaneous exercise 6a. Let us try to solve the example number 15th. In the 15th example, question is to find out the coordinate of the foot of perpendicular drawn from this point to this line. So let us denote this point by what? P, and coordinate of the given point are 0, 2, 3, and a perpendicular is drawn from this point on this line. So let this will be our line. This is the equation of line is given to us, and from this point P a perpendicular is drawn on this line. Here foot of perpendicular I have denoted by what? M. Now question is to find out coordinate of this foot of perpendicular, means our aim is to find out coordinate of point M here. So what is our supposition? That M be the foot of perpendicular drawn from this point on this line. Let us denote this equation, say by equation number first, and all these three terms are equal. Let us denote its value, say by what? Lambda. So I am denoting this value by lambda, isn't it? Now M is a point lie on this line. That's why from this equation we are able to find out coordinate of point M. So therefore we can say that coordinate of point M R. So from this equation let us first try to find out x coordinate. So x will be equals to what here? Consider that this term and lambda are equal. Let us consider that these two terms are equal to find out value of x coordinate. So 5 will get multiplied on this side, means 5 lambda, and plus 3 on this side will become minus 3, means what will get? Minus 3 plus 5 lambda. Considering that these two terms are equal, we are able to find out value of y, means y coordinate. So 2 lambda and minus 1 will become plus 1, means 1 plus 2 lambda. And by considering that these two terms are equal, let us try to find out value of z, means z coordinate. So 3 lambda and plus 4 on this side will become minus 4, means minus 4 plus 3 lambda. In this way we have got the coordinate of point M. Means to find out, we have got the foot of perpendicular. M is nothing but what? Foot of perpendicular, but one unknown value appears in it. What is that unknown value? Lambda. Now we are trying to find out value of lambda using the given condition. What is our observation here? This line PM and this given line, means this line, are perpendicular to each other. And if two lines are perpendicular, at that time their direction ratio satisfies which condition? That A1A2 plus B1B2 plus C1C2 is equal to 0. So to apply this condition, we will require the direction ratio of both the line. So first we are finding direction ratio of this given line. From the equation we can say that direction ratios of line first are, what are the direction ratios here? 5, 2, 3. 5, 2, 3. Let us denote these direction ratios by A1, B1, C1. I am denoting this by A1, B1, C1. Now we are trying to find out direction ratio of which line? PM. So coordinate of P is also known and coordinate of M is also known. If coordinate of 2 points are known to us, then direction ratios can be found out as what? X2 minus X1, Y2 minus Y1, Z2 minus Z1. Use this method to find out direction ratio of line PM. So therefore direction ratios of line PM are. So what are the direction ratio? X2 minus X1 means minus 3 plus 5 lambda minus 0. Y2 minus Y1 means 1 plus 2 lambda minus 2, and Z2 minus Z1, that is minus 4 plus 3 lambda minus 4 plus 3 lambda minus 3. Okay, so here again observe here X2 minus X1, again then Y2 minus Y1, and lastly Z2 minus Z1. So now let us simplify it. Minus 3 plus 5 lambda, keep it as it is because 0 is there, minus 3 minus 0 is minus 3. Let us simplify it. 1 minus 2 is minus 1 plus 2 lambda, keep it as it is. Here minus 4 minus 3 is minus 7 plus 3 lambda. Denote these direction ratios by A2, B2, C2. Let us denote it, say by A2, B2, C2. Now direction ratios of both the lines are known to us, and here these two lines are what? Perpendicular. So since line PM and line first, means this line which you are denoted by equation first, are perpendicular, that's why we can say that direction ratio satisfies which condition? A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Now remaining part is just to substitute the value. These are the values of A1 B1 C1 and these are the values of A2 B2 C2. A1 A2 means phi u into minus 3 plus phi u lambda. B1 B2 plus 2 into minus 1 plus 2 lambda, and C1 C2 means plus 3 into minus 7 plus 3 lambda is equal to 0. Now simplifying it, we will try to find out value of lambda here. So here we will get minus 15 plus 25 lambda. So here we will get minus 2 plus 4 lambda, and lastly minus 21 plus 9 lambda is equal to 0. On one side we are collecting the terms of lambda. So 25 plus 4 is 29, 29 plus 9 is 38. 38 lambda is equal to, and on another side we are collecting the constant term. Minus 21 minus 2 is minus 23. Minus 23 and minus 15 is minus 38. Minus 38 on this side will become plus 38, which implies that lambda is equal to what? 1. That is 38 divided by 38 is 1. Once the value of lambda is known to us, substituting the value of lambda here, we will get the coordinate of which point? M. And question is also to find out what? Foot of perpendicular, and foot of perpendicular we have denoted by what? M. So substitute the value of M to find out coordinate of point M. Therefore, coordinate of point M are. So what we will get here? To find out x coordinate, replace this lambda by 1. So 3 plus 5 into 1. Then y coordinate is 1 plus 2 lambda. Lambda is what? 1. Minus 4 plus 3 into 1. So which is equal to 5 minus 3 is 2. So here we will get 3 and here we will get minus 1. So in this way we have got the coordinate of what? Point M means coordinate of foot of perpendicular. Now see the example number 16. In question number 16, two examples are there. So first we are trying to solve first example. In this case, equation of two lines are given to us and we have to find out shortest distance between two lines, and later on we have to check whether the lines are intersecting or not. If shortest distance between two lines is 0, we can say that lines are intersecting, and if it is not equals to 0, we can say that lines are not intersecting. So means to check whether lines are intersecting or not, we have to find out shortest distance between two lines. As is stand in the first example, equation of both the lines are in vector form, and we have a formula to find out shortest distance between two lines. What is that formula? A2 bar minus A1 bar dot B1 bar cross B2 bar divided by magnitude of B1 bar cross B2 bar. To apply this formula, which four values are required? A1 bar, B1 bar, A2 bar, B2 bar. These values we will get from the equation of two lines. So from equation number first, we can say that A1 bar is equal to, what is the value of A1 bar here? I cap plus J cap minus K cap. B1 bar is equals to, B1 bar is equal to 2I cap minus J cap plus K cap. From the second equation, we will get the value of A2 bar, that is 2I cap plus 2J cap minus 3K cap, and B2 bar is equal to I cap plus J cap minus 2K cap. Once these values are known to us, now we are trying to find out value of this numerator. To find out value of this numerator, we will require the value of A2 bar minus A1 bar. So let us try to find out value of A2 bar minus A1 bar is equals to. Substitute the value of A2 bar, that is 2I cap plus 2J cap minus 3K cap minus I cap plus J cap minus K cap. Just simply we are taking subtraction of these two vectors. Now first collect the terms of I cap, that is 2I minus I will be equals to I cap. Then 2j cap minus j cap will be equals to j cap, and lastly minus 3 and minus minus means plus 1. Minus 3 plus 1 will be equals to what? Minus 2. Minus 2 k cap. In this way we have got a2 bar minus a1 bar, which is the second required value, b1 bar cross b2 bar. Now try to find out cross product of these two vector, b1 bar cross b2 bar. We know that cross product can be found out using determinant. In the first row write down basic vector I, j, k. Then what are the coefficients here? 2, minus 1, 1, and here coefficients are 1, 1, minus 2. Let us simplify it. First find out the coefficient of what? I cap. So for that purpose delete this column. Here this product is 2, 2 minus 1 is 1, so not necessary 1 here. Then second, then here plus j cap is there, so that's why we are taking minus j cap. Now we are trying to find out coefficient of what? J cap. So delete this column. Minus 4 minus 1 is minus 5, minus, and this minus will become plus 5. Lastly, let us try to find out coefficient of what? K cap. So delete this column. This product is 2. 2 minus minus means plus 1. 2 plus 1 will be equals to 3. In this way we have got the value of what? Cross product. Now we are finding magnitude of b1 bar cross b2 bar, because this value will required in the denominator. b1 bar cross b2 bar, its magnitude is equals to, so what we'll get here? Under root 1 square plus 5 square plus 3 square, so which is equals to under root 25 plus 126 plus 9 35. So here we'll get under root 35. Now we are finding dot product of these two vector. Which two vector? a2 bar minus a1 bar and b1 bar cross b2 bar. So which is equals to, first substitute the value of a2 bar minus a1 bar. What is its value? I cap plus j cap minus 2k cap. Dot, keep it as it is. Now substitute the value of this cross product. What is the value of cross product? I cap plus 5j cap plus 3k cap. So which is equal to, now take the dot product here. First, while taking dot product, first we are taking product of coefficient of I cap, that is 1 into 1 will be equals to 1, then 1 into plus 5 will be equals to plus 5, and minus 2 into 3 is minus 6. So here 1 plus 5 6, 6 minus 6 is equal to 0. So all the values are known to us. Remaining part is just to substitute these values in this formula. So what is the value of this numerator? Value of this numerator will be equals to 0. So replace this numerator by 0, and in the denominator we are substituting the value of what? Magnitude of b1 bar cross b2 bar, where magnitude is equal to what? Under root 35. So which is equal to 0 divided by any number is 0, and mod of 0 will be equals to 0. So what result we have got here? Shortest distance between given two line is equal to 0, and if distance between two line is 0, at that time what is our conclusion? That lines are what? Intersecting. So hence we can say that given lines are intersecting. And this is the that's what we have to check here. Means to check whether lines are intersecting or not, we have to find out first what? Shortest distance. Once the shortest distance is known to us, we are able to conclude that lines are intersecting or not intersecting. As this stand distance is 0, that's why our conclusion is what? Lines are intersecting. Using same method, let us try to solve the second example from the question number 16. Now we are starting second example from question number 16. In this case, equation of two lines are given to us, but equations are in Cartesian form. In the last example, equations are given in what? Vector form. So now just observe these two equations. So this is the equation of first line, and this is the equation of what? Second line. Here nothing is in the denominator, means 1 is always there in the denominator, isn't it? So from this equation, first we will try to find out value of a1 bar, b1 bar, then a2 bar, b2 bar. Once these four values are known to us, then this formula is applicable to find out what? Shortest distance between two lines. So here we are supposing that a1 bar is what? Position vector of a point on the line first, and b1 bar is what? Vector along the line first. Let us denote these vectors by a1 bar and a2 bar. So let a1 bar be the position vector of point on line first, and b1 bar be the vector parallel to this line. Okay, parallel to this line. So therefore a1 bar is equals to and b1 bar is equals to. So if you'll observe this equation, from this equation we are able to find out coordinate of a point on the line. Once the coordinate are known to us, we are able to find out its position vector also. So what are the coordinate here? Here -5 is there, means +5 will be the x coordinate. Here y coordinate is 7, and here +3 is there, means -3 is the z coordinate. Means this is the coordinate of a point on the line first, from which we will get position vector of that point 5i cap plus 7j cap minus 3k cap. Once this value is known to us, now we are finding value of b1 bar. Value of b1 bar means b1 bar is what? Vector along the line, or we can say that vector parallel to the line. From the direction ratios we will get the value of b1 bar. So what will the value of b1 bar here? 4i cap plus 5j cap plus 5k cap. And now let us denote the position vector of a point on the line second by a2 bar. a2 bar be the position vector of point on line second, and b2 bar be the vector parallel to this line. Therefore a2 bar is equals to, now what is our supposition? a2 bar is the vector is the position vector of a point on the line second. From this equation first find out coordinate. So x coordinate is 6, y coordinate is what? 8, and z coordinate is how much? -2. So here from this coordinate we will get the value of a2 bar, that is 6i cap plus 8j cap minus 2k cap. And b2 bar is equals to, b2 bar is what? Vector along this line or vector parallel to this line. From this direction ratio we can say that its value is equal to I cap plus j cap plus k cap. Once all these values are known to us, now we will try to find out value of this numerator. For that purpose first we have to find out subtraction of what? a2 bar and a1 bar. So therefore a2 bar minus a1 bar is equals to, what is the value of a2 bar here? 6i plus 8j minus 2k minus value of a1 bar. a1 bar is equal to 5i cap plus 7j cap minus 3k cap. So let us take the difference of these two vectors. 6i minus 5i will be equals to I, 8j minus 7j will be equals to j, and minus 2 minus minus means plus 3. Minus 2 plus 3 will be equals to 1. 1 means 1k cap. So in this way we have got the value of a2 bar minus a1 bar. Now we are finding the second required value, that is cross product. So cross product of what? b1 bar and b2 bar. So therefore b1 bar cross b2 bar is equals to, let us try to find out this cross product using what? Determinant. So in the second row write down the coefficients from b1 bar, that is here coefficients are 4, 5, 5. So 4, 5, 5, and coefficients of I cap, j cap, k cap from b2 bar are what? 1, 1, 1. So are 1, 1, 1. So which is equal to, first try to find out coefficient of I cap. 5 minus 5 will be equals to 0. Then plus j cap is there, so take minus j cap, delete this column. 4 minus 5 is minus 1, minus and this minus will become plus 1, not necessary to write plus 1 here. Lastly we are finding coefficient of k cap. 4 minus 5 is minus 1, so here we will get minus 1, not necessary to write 1 here. So what value we have got here? J cap minus k cap. Now we are finding magnitude of this vector b1 bar cross b2 bar, because this value will required in the denominator. So under root 1 square plus minus 1 square is equals to what? Root 2, because square of minus 1 is also plus 1. 1 plus 1 will be equals to 2. Lastly, we will find out dot product of these two vectors, and a2 bar minus a1 bar dot b1 bar cross b2 bar is equals to. Now what is the value of a2 bar minus a1 bar? So I plus j plus k, and this is the value of what? b1 bar cross b2 bar. Whenever we are taking cross product, first we are taking product of coefficient of I cap, means 1 into 0 will be equals to 0, plus then take the product of coefficient of j cap, 1 into 1 will be equals to 1. Lastly, take the product of coefficient of k cap, minus 1 into 1 will be equals to minus 1. So this value will be equals to 0. Let us substitute all these values in this formula. So value of this numerator will be equals to 0, and value of this denominator is equals to root 2. And 0 divided by any number will be equals to 0. So what result we have got here? Shortest distance between given two line is equals to 0. Means what is our conclusion here? The lines are intersecting. Since distance is 0, that's why we can say that given lines are intersecting. Hence, given lines are intersecting. And this completes the solution of this example.